Hey, welcome to The Explainer. Today, we're cracking open the doors to one of the most amazing, non-stop factories in the entire universe. And it's inside you. We're going to look at how your body builds its own blood, a process that is, no joke, defining your health every single second.
Think about it. Right now, whether you're sitting, standing, or even sleeping, your body is hard at work. It's running a massive, total internal renovation. It's this silent, tireless project that literally keeps you going.
Okay, just let this number sink in for a second. 100 billion.
I mean, that is just a staggering number. That's more than the number of stars in some galaxies. And your body is churning these out daily to replace the old ones. It is an assembly line on a scale that's almost impossible to imagine.
It seems impossible, right? A production line that never ever stops, from the moment you're conceived till your last breath. Well, the secret is this beautifully complex, elegant process, and we're about to dive in and see exactly how it works.
All right, so every great factory has a name, a technical term for its main operation. Let's get to know the name for this one and what it's all about.
The process is called hematopoiesis. It sounds super scientific, but if you break it down, it's pretty simple. It comes from the Greek words for blood, that's haima, and to make, poiesis, blood making. But here's the really wild part. This entire massive operation, all those billions and billions of cells, they all come from just one single type of master cell.
And this isn't some temporary gig. The factory opens for business when you're just an embryo, starting out in the yolk sac of all places. Then it moves to the liver and spleen. And finally, it settles into its permanent headquarters for the rest of your life. It is absolutely fundamental for survival.
So where is this permanent factory? Where's the HQ? Well, we have to go deep inside our own bodies, into the spongy, living tissue right inside our bones. We're going to the bone marrow.
You know, the bone marrow is less like a single factory floor and more like a bustling city. It's made up of all these different neighborhoods, or niches, as they're called. Each one has its own vibe, its own local conditions, and for a stem cell, its address, which neighborhood it's in, is the very first signal that tells it what its job is going to be.
Let's check out two of the main neighborhoods. First, you've got the arteriolar niche. It's near the smaller arteries. Think of this as the quiet residential suburb. It's a protected area where stem cells are kept dormant or quiescent, just kind of hanging out, preserving their power for later. But then you've got the sinusoidal niche. This is downtown. It's near the bigger, leakier blood vessels. This is the busy, active district where the stem cells get all these signals from the bloodstream basically yelling, "Hey, you, time to get to work."
Okay, so let's follow one of these cells on its adventure. We're going to trace the path of this master cell as it decides what it wants to be when it grows up.
So meet our hero, the hematopoietic stem cell, or HSC for short. This is the master blueprint, and it has two superpowers that are just incredible. First, it can differentiate, meaning it can become any type of blood cell, red cells, white cells, platelets, the whole shebang. And second, it can self-renew. It can make perfect copies of itself. This is absolutely crucial because it means the factory supply of these master blueprints never ever runs out.
Okay. All right, take a deep breath. This is it. This is the full family tree of our blood cells. And yeah, it looks super complicated. You see all these different branches and specialized roles. But don't worry. As complex as it looks, this entire tree grows from one single trunk and one critical fork in the road. So let's break it down. It really just comes down to this. Step 1, you start with the originator, our HSC. Step 2, that HSC comes to a huge fork in the road. It has to make a choice. It commits to one of two main paths. Either the myeloid path, which will lead to things like red blood cells and platelets, or the lymphoid path, which makes other kinds of immune cells like T cells and B cells. And from there, they go on to become the specialists that our body needs to function.
And here's a little cheat code to help you understand the lingo here. As these cells grow up, their names actually follow a pretty simple pattern. They often start as a blast cell, like a myeloblast. Think of blast as a baby, an immature cell. Then they mature into a cyte, which is more like a teenager or a young adult cell. This little naming trick helps scientists track a cell's journey from a total rookie to a fully fledged professional.
So this factory is an incredibly fine-tuned machine. It's a marvel. But what happens when the production line gets messed up?
well, the consequences can be pretty serious.
The health of that bone marrow city is all about balance, and outside factors play a huge role. Good things, like regular sleep and exercise, help keep everything running smoothly. But negative things, chronic stress, high cholesterol, diseases like diabetes, they can throw the whole system out of whack. They interfere with key signals, like one called CXCL12, which is the chemical message that tells stem cells to stay home in their quiet neighborhood. When that signal gets messed up, the stem cells get the wrong message and start producing the wrong kinds of cells, often inflammatory ones.
And when that production line gets unbalanced, we see very real medical conditions. If you don't make enough red blood cells, you get anemia, which is why you feel tired and weak. Not enough white blood cells? That's leukopenia, and it puts you at a much higher risk for infections. And if you have too few platelets, that's thrombocytopenia, and it can lead to dangerous, uncontrolled bleeding.
And this is why this whole process is so critical for our long-term health. As we get older, or if we have conditions like cardiovascular disease, the neighborhood itself, the niche, can get damaged. And this creates an environment that basically pushes stem cells down that myeloid path, churning out way too many inflammatory cells, which then makes those diseases even worse. It becomes a really vicious cycle.
But it is not all doom and gloom. Not at all. The amazing thing is that science is now figuring out how to get inside the factory and, just maybe, take control of the production line ourselves.
This really is the billion-dollar question that researchers are trying to answer right now. If hematopoiesis goes wrong, if the factory is broken, can we actually step in and repair it? Can we fix genetic diseases right at their source?
And one of the most exciting new frontiers is the use of nanoparticles. Seriously, think of these as microscopic delivery drones. They can be built from different materials, lipids, polymers, and you can load them up with a cargo of genetic tools like CRISPR and send them on a mission to deliver new instructions directly to those HSCs inside the bone marrow.
Of course, not all delivery drones are the same, and scientists are trying to figure out which model is best for the job. You've got polymeric nanoparticles, which are sturdy and have a long shelf life. You've got lipid-based ones, which are great at sneaking their cargo past the cell's defenses. There are even metallic nanoparticles, made of things like gold, that can carry a really heavy payload. Each one has its pros and cons, and the race is on to find the perfect vehicle for the job.
And this, right here, this brings us to the ultimate goal. The ability to fix the blood factory inside the body could completely revolutionize medicine. As this quote says, it could make powerful genetic cures for diseases like sickle cell and HIV accessible to everyone, everywhere. It's a future where we don't just treat symptoms, we actually go in and repair the blueprints of life itself. That is a future worth fighting for.